Good day, favorite. Welcome back to another episode. Today we're talking about alternating current circuits, also known as what AC circuit. We are going to discuss the current in an AC circuit, the voltage in an AC circuit, graphical representation, resistance, inductance, capacitance in a circuit, resonance frequency, and so on, and make sure we bring out all formulas necessary to evaluate problems related to this topic. And if you're a student, SSC, UTME, make sure you're on my YouTube channel. Link in my bio, favorite tutor. Please go there and subscribe. There you get the full package. Okay, AC circuits, alternating currents or alternating voltage is that which varies periodically. It has the same graphical representation of what the sine waveforms. It varies periodically. And the alternating current circuit, that is the circuit. It is circuit in which alternating current flows. I hope you get that. Okay. Now, for the alternating current in the circuit is given by I equals to what? I naught sine omega time. This is the instantaneous current. This is the peak current. That's the maximum numerical value of the current. And this is the phase angle. Omega times time, and this is angular speed. Angular speed is known as what? Or angular velocity, as the case may be. Angular velocity is what? 2 pi f. If we substitute this into this, we have it that the current is equals to I naught sine 2 pi f what? T. Now this is the current in the circuit. For voltage, it's the same thing as V equals to what? V naught sine 2 pi f T. Now this is what? Voltage. V stands for what? Instantaneous voltage. V naught, peak voltage. Then we have the frequency and what? Time. I hope you get that. Please make sure you're writing this thing down, because this my board is very big. I don't think it's enough, but it's very big. Okay, let's continue, because I'm going to clean some parts and put down some information. Now let's talk about what the peak values. Peak and root mean square values. The peak values of the current, we are talking about the maximum numerical values of the current, is denoted with what? I naught. And for peak voltage, that is what? V naught. Maximum numerical values of the what? Voltage. For root mean square value of the current, we are talking about what? The steady current that flows in the circuit. The steady current that flows in the circuit, which will dissipate heat at the same rate in a given resistance. And they have the relationship of the way they are related. This is what the root mean square is equals to what? I naught over what? Root 2. Same thing as for voltage, root mean square. That is what? V naught over what? Root 2. If we evaluate this expression, is equals to what? 0.707 I naught. And this is what? The same thing, 0.707 V naught. When we evaluate this is 1 over root 2, this is 1 over root 2. Then we have it I naught, V naught, as the case may be. See that it is what? Very simple. Make sure you are taking this thing down. Okay. Now let's discuss resistance in the circuit, capacitance in the circuit, inductance in the circuit. Okay. Now, for resistance in the circuit, resistance. Okay, let me just put it like this. Resistance in what? AC circuits. If this is the circuit, this is a resistor. This is what? The ammeter. Right, this is the source. AC voltage source. AC voltage. This is resistance. And of course, the voltmeter. Right here. See, for what we have here, if an AC voltage is connected across a resistance, now what's going to happen? If an AC voltage is connected across the resistance, the current that flows through this resistance and the voltage, they are in phase with each other. They are in phase. That means we can say they are what? Parallel with each other. I think that's good. They are in phase with each other. The same angle with each other. So, let's say for graphical representation for this is what? Voltage and what? Current against what? Time. Now, if this is the what? The voltage. If this is the what? The voltage. This is the what? The current. You see, they are in phase with each other. They attain maximum at the same time, the 0 point at the same time, and minimum at the same time. They are in phase with each other. In the sense that we can say they are parallel with each other. Here, this is what the voltage across the resistance, and this is what the current across the resistance. They are in what? Parallel with each other. The same angle, the same phase angle. They attain their maximum value 0 and what minimum at the same time. All right, let's talk about what? Capacitance. For capacitance in an AC circuit. But before we discuss capacitance, we can, from Ohm's law right here, we know that for this resistance, from Ohm's law says that this is V equals to what? IR. If we make I subject formula, I is equals to V over what? R, which we have it here. And the ammeter and the voltmeter, they measure the root mean square values of the current and voltage, respectively. So therefore, this is I, measure the root mean square values is equals to what? This is what? That is what root mean square values, then over the resistance. From here, we can deduce the fact that what I is equal to what is V. This is what V. You know that what this is V naught sine omega time all over what R, which is the same thing as what I naught sine omega what time. See that I the same thing as this. This is what V, root mean square value, which is what V naught sine omega time. This over this, V over R, V over R, the same thing as what I. So it's what I naught sine omega what time. I guess this is what clarified. Okay, capacitance. Now let's go to capacitance. Capacitance. Make sure you are taking this thing down. You can pause the video and take it down. For capacitance, okay, I'm going to clean this resistor and use what? Capacitor. This is what? Capacitor. C. And of course, for those of you on my YouTube channel, we have done this before. Capacitor. Capacitor is measured in what? Farad. Okay. Now, for this, the current and the what? Voltage. In this case, the current and voltage are out of phase. They are out of phase. In the sense that the current is leading and the voltage lags behind. They are out of phase. The phase angle, they are out of phase. The current is leading with an angle of what? 90 degrees. The current leads with an angle of 90 degrees, and the voltage do what? Lags behind. Graphical representation for this. This is what? Voltage and what? Current. Voltage and current against what? Time. Now, if this is the voltage, the current is leading. The current is leading with 90 degrees. I'll be like this, something like this, leading with 90 degrees. There's the current. So therefore, if I say that the voltage, if this is the voltage, V equals to what? V naught sine omega time. This is the phase angle. Now for current will be what? In this case, current will be what? I naught sine, then the phase angle plus what? 90 degrees. 90 degrees is the same thing as what? Pi over what? 2. Because for angles, pi is what? 180. Pi over 2. So this is for the current. In this case, when what? You connect what? When an AC voltage is connected across a capacitor. So they are out of phase in the sense that the current is leading. Out of phase, that means since it's 90 degrees, we can say they are perpendicular to each other. Perpendicular to each other. So this is the current in the what? Capacitor. What is the voltage in the capacitor? They are what? Perpendicular to each other. And the current is what? Leading. You can see that it is clear. Clarify. Current is leading. Now, from Ohm's law, more reason you have to be on my YouTube channel. Please make sure you are there. Please, let me beg. Make sure you are there. Okay, from Ohm's law, we know that what? V is equals to what? IR. I stands for what? Current. Why D stands for what? Resistance. In this case, this capacitor has the ability to oppose current, the flow of current. The ability for this capacitor to oppose the flow of current is called what? The capacitive reactance. Capacitive reactance. And it's denoted with what? X subscript what? C. Denoted with X subscript C. Capacitive reactance. And is equals to 1 over what? Omega C. This is what? The capacitance of the capacitor. This is the same thing as what? 1 over 2 pi F what? C. The capacitive reactance. That is the opposition of the flow of current by the what? Capacitor. So from Ohm's law, instead of using what? We are going to remove this what? Resistant and impose what? Capacitive reactance. So therefore V is equals to what? I X what? Subscript what? C. And of course this is measured in what? Ohms. Those are the resistance measured in ohms. In this case, this is also measured in what? Ohms. This is also opposition to the flow of current. It takes the same definition with this. Just that in this case, this is not resistor. This is what? Capacitor. So we are using this. Okay, capacitive reactance. Now from here, that is what? 1 over what? Omega C. C stands for what? Capacitor. That is the capacitance of the capacitor, which is measured in farad, while this capacitive reactance is measured in what? Ohms. Make sure you are taking this thing down. This is measured in ohms. I is measured in ampere. And of course, the voltage is measured in volts. Okay, I guess that's that you need to know for this. All right, is there any other information? If I remember, we'll just impute it. Okay, let's talk about what? The inductance. In an AC circuit, inductance. Inductance. Okay, I have to clean this. So when we clean this also, we put the inductor. The inductor is a coil. And this is the inductor, denoted L. The inductor is measured in Henry. Just take this information down. It's measured in Henry. This is what the AC voltage. All right. In this case, when an AC voltage is connected across an inductor, in this case, the inductor or the voltage is what? Is leading with the current, and the current do what? Lags behind with what? 90 degrees. So if the voltage V is equal to what? V naught sine WT. Now what is the current in this case? The current will be what? I naught sine. The phase angle, this current lags behind your WT minus what? Pi over 2. It lags behind. So therefore the voltage across the inductor is leading the current that flows through the inductor with what? 90 degrees. The current do what? Lags behind. So in the sense that they are also what? Perpendicular to each other. Now if this is the what? The current that flows in the inductor, This is what the voltage that flows in the what? Inductor. They are perpendicular to each other. Current do what? Lags behind. All right, am I missing anything? Okay, from Ohm's law, let's use Ohm's law. V is equals to what? I arrow. Now, what is the resistance right here? This inductor has the ability to oppose current also. The opposition to the flow of current in this case by this inductor is known as what? Inductive reactance. Inductive reactance. That is the word. Reactance. The opposition to the flow of current by the words inductor, and is denoted with what? X subscript what? L. Also measured in what? Ohms. So, which is equals to what? 2 pi omega what? L. The same thing as what? 2 pi FL. Sorry. Yeah, 2 pi what? FL. No. This is what? Omega what? L, which is what? 2 pi F what? L. F stands for the frequency, while L stands for what? The inductance of the inductor, measured in what? Henry. Okay. So therefore, we can say that what? V is equals to what? I X subscript what? L. That is Ohm's law application in this case. Hope we are good. Of course, we are good. All right. Now let's discuss series connection. For series connection. Okay, make sure you are taking these formulas down. Series connection. Series circuits. Series circuits. Let's say we are using the first one we should use is for, let's say, capacitance and what? Resistance. Let's say capacitance and resistance. Now, if this is the circuit, this is the what? The capacitor. Why this is the what? The resistor. All connected to the what? The source. The AC voltage. The AC voltage is the capacitor. Why this is the resistor? You know that the current that flows through the capacitor and resistor, they are what? They are the same. The current that flows through these two circuit components, they are what? The same. But the voltage across it are what? Different. The voltage across it are what? Different. But the current that flows through it are what? The same. But the voltage across these two are what? Different. If the voltage are different, we are going to get the effective voltage across the two. So that's what we are going to look for right here, the effective voltage across the two. But since we know that the current that flows through this resistor is parallel, if this is the current, the current that flows through it is parallel to the resistor, is parallel to the voltage that flows through the what? Resistor. It's parallel to the voltage that flows through the resistor. And the same current that flows through the current that flows through this capacitor is perpendicular to the voltage across the capacitor. Perpendicularity 90 degrees. So this is the voltage across the what? Capacitor. Hope you can see this. That means we can say that the voltage across the capacitor is perpendicular to the what? Voltage across the resistor. I hope you get that. The voltage across the capacitor is perpendicular to the voltage across the what? Resistor. These two, they are parallel to each other. While these two, they are perpendicular to each other. If these two are parallel to each other and these two are perpendicular, in the sense that these two are what? Perpendicular to each other. And of course, this is a what? A vector field. Now, if this is a vector field, for us to get the effective voltage in this what? Circuit across these two, the effective voltage in this across these two, we use what? Triangular law of vector to get the effective voltage. Triangular law of vector. This is the what? The voltage across the two. The effective voltage across the two circuit components. The effective voltage. Triangular law of vector. The same thing as what? Pythagoras theory. Setting a Pythagoras theory, since they are what? Perpendicular law. Since they are what? Perpendicular to each other. So therefore, we can say that what? V is equals to what? V arrow raised to the power of 2 plus what? V, let's start with C. VC raised to the power of 2 plus V arrow raised to the power of what? 2. Okay, let's move further. So therefore, V is equals to square root VC raised to the power of 2 plus what? V arrow raised to the power of 2. So that is V is equals to square root. What is VC? VC from Ohm's law, that is what? Ix subscript C raised to the power of what? 2 plus, this is what? Let me remove this first of all. The square root. Let me put it here. As we are going, we'll bring it back. Plus what? This, in Ohm's law, this is what? I arrow raised to the power of what? 2. The current that flows through, they are what? The same. So we just do what? Factorize the current. This is what? I bracket what? I square bracket what? X square plus what? Arrow square. Yeah, as the case may be. So therefore, take the square roots. V is equal to what? Square roots I square bracket what? This is what? XC raised to the power of 2 plus what? Arrow raised to the power of what? 2. Square root of this is I, it comes out. So V is equal to what? I square root X C raised to the power of 2 plus what? R raised to the power of what? 2. So this is the what? The voltage across it. The effective voltage in this circuit. Okay, if I make I subject formula from here, let's make I subject formula the current. Make I is equals to what? V over what? Square root X S subscript C raised to the power of 2 plus what? Arrow raised to the power of what? 2. Now, all this is known as the what? The opposition to the flow of currents. So therefore, this square root X subscript C raised to the power of 2 plus what? Arrow raised to the power of 2 is known as what? Everything here is known as what? The opposition to the flow of current offered by the circuit component altogether in this circuit. Just like from Ohm's law now, we know that from Ohm's law, V is equals to what? I arrow. If I make arrow subject formula, this arrow right here is known as the opposite, that's the resistance. In this case, this is the what? Resistance. Because if we make I subject formula right here, is equals to what? V over R. So this is the what? The opposition to the flow of current right here in this scenario. And then in this case, we call it the impedance. We call this the impedance, which is equals to what? Z is equals to Z. So therefore, I is equals to what? V over what? Z. Z represents what? The impedance in this scenario. So therefore, Z is equals to V over what? I. This is the impedance. And the impedance is the what? Opposition to the flow of current offered in a what? In a series circuit by the circuit components of an AC what? Circuit. Okay. Now, this is the what? The impedance. All right, we are going to do another one, another series combination that we are using. Let's say we are using what, the inductance and what, resistance, and also get the what, the impedance in that case. All right, make sure just take this thing down, take it down. Then we look at this other scenario, inductor and what, resistor. Okay, so I'm going to clean everything right here. See that the board is beautiful. Clean everything right here. We'll go again. Please make sure you are taking the formulas. So you are using inductor and resistance. Okay. Just clean here. Inductor. And the inductor is a coil. This is the inductor. This is the resistance. Okay. Now, in this case, the current that flows through them are what? Actually the same. It's just the same thing we are going to do right here. The same thing we are going to do right here. Just that in this case, is what? Inductor. This is what? Resistance. And also, the current and the voltage right here, they are parallel to each other. Current and voltage offered by the resistor. Sorry. The current that flows through the resistor and the voltage across it, they are what? Parallel to each other. If this is what, the current resistor and the voltage in the resistor, they are parallel to each other. And also the current is what? Perpendicular to the what? Inductor. To the voltage of the across the inductor right here. So therefore voltage across the what? Inductor. They are perpendicular to each other. We look for the word, the effective voltage. We also use what? Triangular law of vector. Using triangular law of vector, so that is V is equals to what? Square root V subscript L plus what? Arrow subscript L is power of 2. The same thing we are going to do. And then if we do this, we are going to have it that V is equals to, that is I square root. This is in Ohm's law, we have this is x L raised to the power of 2 plus what? Arrow. Sorry, no, this is V subscript what? Arrow. Arrow raised to the power of what? 2. So we are going to have it like this as the voltage right here. Then what is now the impedance in this case? This is now the impedance in this case. Therefore, the impedance, which is equals to what? Square root x subscript L raised to the power of 2 plus what? Arrow raised to the power of what? 2. You can see as the what? The impedance. Same way, Z is equals to what? V over what? I, which is equals to what? X to the power of 2L plus what? Arrow raised to the power of 2. That's what? Impedance in this case. Okay, which other one again? All right, we are going to look at inductor and what? Capacitor. Inductor and what? Capacitor. And see what is going to give us in this case. Inductor and capacitor. Okay. Make sure you take this thing down. Take it down. All right. Inductor. Okay, there's a capacitor. Okay, can always pause the video and get the information. All right. Now the current that flows through the inductor and capacitor actually the same. Series connection. Current is the same across the circuit components. Current are what? The same. Okay, this is the what? The currents. And then the same current is perpendicular to the what? To the voltage across the capacitor, V subscript C. And the same current is what? Perpendicular to the what? Voltage across the inductor, V subscript what? L. You can see that the voltage across the what? Inductor is parallel, that is opposite direction to the what? Voltage across the what? Capacitor. You can see they are in what? Opposite direction. set apart. So this is a vector field. In this case, to get the what? To get the voltage. To get the voltage right here, just normal subtraction. Just for us to subtract. The voltage here is going to be what? Let's say VL minus what? VC. So long that what? V subscript L is greater than what? V subscript C. The voltage right here is the positive difference of these two. That's the effective voltage. Positive difference of the two. Okay, so therefore this is V is equals to, what is this? I x subscript L minus what? I x subscript C. So therefore V is equals to, I is the same across both of them, the same. So we just factorize, we have it that this is x subscript L minus what? X subscript C. So this is the impedance in this case. So the impedance, which is Z, is equals to what? V over I, which is equals to what? X subscript L minus what? X subscript C. In this case, you can see how easy it is. Okay, all right. Make sure you subscribe to the YouTube channel. In our next class, we are going to discuss, or we should just discuss it. Okay. In our next class, we are going to talk about what? The 3-in-1 circuit components, when we have the inductor, capacitance, and resistance in an AC circuit all together. Stay tuned. Thank you. Have a nice day.